simplify I to the power of 90. Now if we are to simplify I to the power of 90, we need to go back to our main definition. We know that I is equal to the square of -1, but that's not going to help us. We also know that if we square both sides, the square root and square root cancel. So I squared is equal to -1. And this is the definition that we are going to be using. So I need to find how many I squares are in 90. I know that I squared, how many I squares are in 90 are 45. And if you're not sure, you can just use the long division. Now I'm going to substitute the I squared by replacing it with the value of I squared, which is -1, and to the 45th power. As you multiply -1 by itself 45 times, because this is odd, your answer will be -1. And there's no i's left. Remember, -1 times a -1 becomes a positive. And then if you multiply by -1, it's a -1. If it's even, +1. If it's odd, -1. If it's even, +1. Letter B. First, how many I squares are in 45? We have 22 of them, because 22 times 2 is 44, and we have 1 extra. Next, I'm going to replace I squared with a -1. The value of I squared is -1, according to our definition, to the 22nd power multiplied by I. -1 to the 22nd power will be +1, since this is even. Whenever you multiply -1 to an even power, or raise it to an even power, gives you +1. And we still have the I left. So therefore it just gives me +I, or just I. Letter C. I to the 39. First, I'm going to use my definition, so I want to find out how many I squares are in 39. Will be 18. Because 18, well actually 19, correct? 19 times 2 is 38, and then I need one more to make it 39. So 2 times 19 is 38, and one more is 39. I'm going to replace I squared with -1. That's our definition. And whenever I raise -1 to the 19th power, because this is odd, will give you a -1. And I still have my I left over. So therefore my answer is -I.